name is Gedenk. I am one of the managing directors of Emotas, and today I'm going to speak about CanOpenFD device design. Well, at the beginning, there's just one slide about the company, what we are doing, why we are working with CanOpen and CanOpenFD. And then there will be a very brief introduction into CanOpenFD. Well, we all have seen the great presentation from Rainer, but all these presentations here will be available later on separately on YouTube. So I had decided that 3 or 4 slides about CanOpenFD might be useful for that. And then the main topics of my presentation will be hardware and software considerations for CanOpenFD device design. Well, yeah, or just a few words about myself. I have studied electrical engineering, and I'm working with Can for more than 20 years now. And we had founded the company in 2012. It had a different name then, and we are dealing with Can and CanOpen for many years. And yeah, we are members in the technical committee, and we work in the CanOpenFD working groups and other ones. And we had a first CanOpenFD stack in 2018. And well, besides CanOpen, we also offer products for other Can and CanFD based protocols. So yeah, that's what we are doing in general. And now I would like to start with the very brief introduction into CanOpenFD. Well, we have heard a lot about it already, but just summary about that. Well, CanOpenFD obviously is a communication network based on CanFD. That's fine, that's clear. And it provides standardized communication services. And I think it's important to highlight that CanOpenFD provides standardized ways to read or write information from a device or to a device, to read in the right parameters, to send signals. So that is one of the biggest benefits of CanOpen and CanOpenFD, to have standardized communication services. And there are also so-called device and application profiles, which define a standardized device behavior and a set of parameters and signals for specific types of devices. And that is also a big advantage of CanOpenFD. Well, the first specification of CanOpenFD had been published in 2017, and if we are talking about CanOpenFD now, we are referring to the version 1.1 of the Canon Automation Specification 1301. Yeah, just to start with CanOpenFD, just assume that this gray box here shall be a CanOpenFD device, and it's, in this example, it's a battery. Batteries are well known. They work for decades, even without Can or CanFD communication. But assume that at some point of time, your customer asks you that your battery shall communicate using CanOpenFD, and it shall be possible to read the voltage or currents or temperature and something like that. And in order to equip the battery with CanOpenFD and CanOpenFD communication services, well, you have to add a so-called object dictionary into your device. An object dictionary in CanOpen is a list of all parameters and signals of a device, which can be read or written via CanFD or CanOpenFD. And these parameters or signals are called objects in CanOpen. And here's just an example. The battery has voltage usually, and according to the device profile for CanOpen batteries, this voltage information is located at the object 6060, subindex 0. It's an unsigned 32 byte value. It's read-only. And well, these 13 volts are represented as this value internally in your battery, in your object dictionary. So And now, as Rainer has explained, there is a USDO service in CanOpenFD which allows us to, for example, read or write parameters, objects, and signals from CanOpenFD devices. And here's just an example how a CanFD message or a pair of CanFD messages may look like to read this battery information here. So we've seen here the object address and below is the response, and we can see the data here. Well, you can also see that in CanFD, the CanFD frames are longer than previously with classical CanOpen. And well, so basic idea here is CanOpenFD provides a way to read a specific information, the voltage in that example, from a device in a standardized way. That's great. So each time a display or a charger could request the battery's voltage, and the battery would respond usually. But it might be even better if we could configure the battery in that way that it would automatically send its voltage information and other data in CanFD messages. And that's also possible with CanOpenFD. Service is called PDO, and you can put multiple objects or signals into a PDO and configure your device to send these CanFD messages cyclically, for example, or on change or something like that. Well, in principle, all the ideas and the principles behind CanOpen has been are still the same. So CanOpenFD, well, is the successor of CanOpen, and it uses what is available in CanOpen, for example, the object dictionary. But of course, the communication is based on CanFD, and it provides higher bit rates and longer messages. And as Rainer has pointed out, when CanOpenFD had been specified, some communication services had been updated or improved. For example, we have longer PDOs and more flexible USDO services, and also the emergency message can contain now more detailed information about the problem which might have occurred. Well, unfortunately, CanOpenFD devices are not compatible with classical CanOpen devices, so you cannot mix them on the same network. But you have possibility to use new features or improved features, for example, like the USDO, which now uses longer the CanFD frames, and it supports routing, as explained, and broadcast, for example. And it's also easier to implement a cross communication between multiple devices using USDOs. And as Rainer has shown as well, the PDOs can be longer now. Well, in his example, the control word had been, or for multiple devices, had been put into a longer PDOs, which allows it to synchronize the information of multiple devices. Here in this example, I show that multiple signals can be put into a longer PDO, so that's also possible to use the extended payload and to synchronize information in one PDO when it receives multiple signals or objects in CanOpen terms at the very same time. But that's basically all for the CanOpenFD protocol now. And now let's look into the development of a CanOpen device. I'll start with the hardware, and I explain something about the software as well. If we want to develop a CanOpenFD device, we need a CanFD controller. That's obvious. And I would recommend to use a microcontroller with an internal CanFD controller. At the moment, there are a lot of microcontrollers and internal CanFD controllers available. The situation was different a few years ago, but now there are you can find many microcontrollers with CAN-FD inside, and there are different CAN-FD controllers inside. And my recommendation, if you would ask me, is to pick a microcontroller with the MCAN module from Bosch inside. In our experiences, it's the most flexible one and the one with the most features, and you can find this CAN-FD controllers in multiple microcontrollers from multiple manufacturers. However, there are other different CAN-FD controllers in the market in different other microcontrollers. And if you have to choose a microcontroller and an internal CAN-FD controller, it's you should check the feature set of this CAN-FD controller. It might be that on the data sheet they promise that they have a lot of FIFOs, a high number of filters or mailboxes or something like that. But you should also check that these features are also available in CAN-FD mode. And there are some microcontrollers which do not support all of these fancy features in CAN-FD mode. And yeah, it's better to check that in advance. Additionally, with CAN-FD, the bit timing is an important topic, and you also should check if your bit timing registers are wide enough, if slow bit rates shall be used. There will be a detailed slide later on for that. So I would just like to tell you that not all CAN-FD controllers are able to handle low bit rates. Yeah, that's basically CAN-FD controllers used internally. Internal CAN-FD controllers is our recommendation. And don't use external CAN-FD controllers with an SPI interface. Well, SPI is a bottleneck, and it is an additional source of errors that might happen. And well, also we always recommend our customers that it's not a good idea to support external CAN-FD CAN controllers. Sometimes the customers convince us with some ways that we develop software for them with an external CAN-FD controller inside. And so we also gained some experience in handling these external CAN-FD controllers. I would still say do not use them, but in some cases, if you have an existing device and if you have to add CAN-FD or CAN-OpenFD connectivity, sometimes it cannot be avoided. Well, but we've also learned that some external CAN-FD controllers are not exactly optimized for SPI. So it seems that some manufacturers of these external CAN-FD controllers have just taken any CAN-FD IP core and put a SPI connection around, and in some situations they require a lot of write-read sequences to read all the data from these external CAN-FD controllers. Yeah, and well, yeah, in our work we sometimes get hardware from a customer and just do the software development, and sometimes it might happen that an external interrupt pin of the CAN controller is not connected, but if you do have that, use that. So, okay, you need a CAN-FD controller. Best way would be an internal CAN-FD controller, but external, if you cannot avoid it, it's also possible. And then you will need a CAN transceivers on your hardware, basically. There are different type of CAN transceivers. There are classical CAN high-speed transceivers up to 1 megabit. They still work on your desk, but you shouldn't use them for any real products. Then there are CAN-FD transceivers, CAN-SIG transceivers, and quite new CAN-SIG XL transceivers. Yeah, CAN-FD transceivers are the first choice, so to say, to start with a development, and they offer they support a higher bit rate up to 5 megabit in the data phase and in line topology, and up to 2 megabit in star topology. Well, that's if these bit rates are sufficient for your application, it's fine to use CanFD transceivers. But at higher bit rates, especially in star topology, there is a ringing in the network caused by reflections. And that's why so-called CAN-SIG transceivers had been developed. And these CAN-SIG transceivers actively suppress the ringing in CAN-FD network. So especially in star topology, at the transition from the dominant level to the recessive level, you might have, or you have, ringing at the transition, and a CAN-SIG transceiver, they reduce the ringing at this edge. So yeah, they allow for higher bit rates both in star topology and in line topology. They actively drive the bus here at the transition, and so the ringing is reduced. And well, there's also the next version of CanXL is coming. It's coming, or it starts to be developed or used, and there are so-called CAN-SIG XL transceivers which have 2 modes, and basically they have a SIG mode, and in this SIG mode they are used, or they transmit the data just like a CAN-SIG transceiver. So that is a choice if you plan to support CAN-XL in the future, but don't have to use these transceivers. If you combine devices with multiple transceivers in one network, they work together as long as the bit rate is below the limits of one of these transceivers. So for example, if you have a CAN-FD transceiver and if the bit rate in the data phase is below 2 megabit, then you can combine that with all other CAN-SIG and CAN-SIG XL transceivers in the SIG mode. So yeah, and so so they work together as long as you do not exceed the bit rate of, for example, the CAN-FD transceivers. Yeah. Additional information about physical layer or physical layer specification can be found in some Canon automation specification. The 601 series provides information about CAN node and system design. Well, there's one document which had been removed, or the content of the document describing the CAN-SIG transceiver has been moved into the CAN specification itself. Yeah. Okay. There was one topic, the bit rates, which Rainer had already shown in his presentation earlier, and for CAN-OpenFD, a set of nominal and data bit rates are defined, and also mandatory pairs of these bit rates are defined. And it's important for CAN-OpenFD that the sample point of all devices in the network are at the same position. And that's why the bit timing, the values for the individual parts of the bit timing propagation segments and phase segments had been specified in detail. And well, I mentioned earlier that you should check if the bit timing registers in your CAN-FD controllers are wide enough if you want to support lower bit rates in the nominal bit rate. For example, if you have a a long CanOpenFD network, and if you want to use 125 kilobit, the propagation segment has to be set to 191, and well, not all CanFD controllers have 8 bit for this value here. So some only have 6 bits, so you are limited to 500 kilobit as the minimum bit rate. For most applications, that will be fine. But if you plan to support low bit rates, this has to be taken into consideration. That's the basic information for hardware development. You need CanFD controllers, CanFD or CAN stick transceivers, and the right bitrate settings. And if you develop a CanOpen device, you also have to develop some software, of course. And the first documents to look into are the CanOpenFD specifications, as mentioned multiple times. The specifications CiA 1301 and the version 1.1 is the most important, or the basic CanOpenFD specification, which defines all the CanOpenFD services, and but there are other specifications as well. As Rainer had mentioned, the CanOpen Manager specification is still some work in progress, and we might need some support. And the others specification will be handled in different presentations later on. So, okay, if you want to develop a CanOpenFD device, I suggest to use a commercial CanOpenFD stack. Well, we develop commercial CanOpenFD stacks, but there are multiple vendors of CanOpenFD stacks, and all the other presenters here in this session or presentation will also offer commercial CanOpenFD stacks. And if you develop a commercial device, it's highly recommended to use a commercial CanOpenFD stack. And most CanOpenFD stack vendors are active in the CanOpenFD specification, though they know what they are doing, or we are doing, and so it's a good idea. The interoperability of different CanOpenFD stacks had also been tested in the past, so it's a good idea, at least a recommendation. The second recommendation would be to implement some flexible and software, so that some CanOpenFD stacks allow to select the protocol if you want to use classic CanOpen or CanOpenFD. It's a startup of the device, so our CanOpenFD stack can do that, others as well. For example, we have an argument here, and if this parameter is set to true, then the bitrate switch will be activated and the CanOpenFD features will be used. Otherwise, the device will be initialized as a classical CanOpen device. This flexibility to select the protocol at startup might support an easier migration to CanOpenFD, and you could offer your product more customers serving both classical CanOpen and CanOpenFD as well. Another recommendation is use tool-driven design. So we offer, that's a tool which is called CanOpen Device Designer, which allows the user to define the object dictionary. And based on these definitions, the device description files are generated. Both the XDD file, which are the device description files for CanOpenFD, but also the EDS file, because some customer tools still use the old EDS file even for new devices. And you using such a tool, it makes sure that the generated files meet the CanOpen specifications. And in our tool, that's also the it also generates some documentation and also some C and H files to make sure that the specification or that all the attributes of an object are the same in the device description file and the implementation and in the documentation as well. Okay, when you start with your first CanOpenFD device development, or any CanOpenFD device development, it's a good idea to have a CanOpenFD capable analyzer. Well, here at the top of the screen, you can see CanFD messages, and they're interesting. If you have 20 years experience with CAN or CanFD, it might be sufficient to look at the pure CanFD messages, but if you start with a CanOpenFD development, it is a very good idea to use a CAN analyzer, which is able to interpret all the CanOpenFD messages according to this CanOpenFD services. So that tells you that there are boot up messages, heartbeat messages, and additional information, USDOs from one node to another. Trust me, it will make things easier if you have such a tool. So basic idea, use analyzers which are able to interpret the message, or maybe comes with features to filter for node IDs and services, and additional capabilities. And if you start to develop a CanOpen device, it's a good idea to have a CanOpenFD manager tool, but probably so if you need a tool or something to communicate with your device and the CanOpenFD manager tool, it's a good idea. And these tools usually can access all the objects and start devices, configure things. And here in this example, there had been a USDO read request as broadcast to the object 1000 subindex 1, and here we can see the results from both nodes in the network. So when you look for such tools, just look for tools which support XDD files instead of EDS files and all USDO transfer types, including broadcast. Then it's a good idea that if they tool support the predefined CanOpenFD bitrate combinations with the correct sample points, of course. And if you develop other devices as well, for example, J9039 FD devices, just a recommendation here, or just an information, they use the different sample points, so it could be a bit complicated here. And in my experience, it is a good idea to have tools that support CanFD interfaces from different manufacturers, because on the last time there had been a shortage at some point of time of CanFD interfaces, and then it's a good idea if you can just switch the CAN interface and don't have to switch your complete tool chain. Well, so to start a CanOpenFD development, we offer a so-called CanOpenFD starter kit. Other companies might offer other products to start CanOpenFD development. You basically need a microcontroller board, some cables, termination resistors, and a CanFD interface. And well, as my last slide, I would like to say something about our complete CanOpenFD toolchain. In addition to a CanOpenFD stack, we also offer CanOpenFD bootloader, update tools, network design tools, device designer, analyzer, and CanOpenFD manager tools. So basically everything you need for a successful CanOpenFD device development.